So I'm curious before I begin, just as a show of hands, who considers themselves working in like a large IT shop or an enterprise? Just curious. Okay, actually a really good portion of you. So I guess what I'm going to see is either some head nodding, like agreement, yeah, I went through this too, or you're going to be like furiously writing down notes to take back to your company. I was going to share a story here about how we stood up Cassandra at Target, and there's a lot of good lessons in here. So I think if you take some of this stuff back to the company you work at, you can get some good stuff out of it. So I'm Dan Cundiff, work at Target. I work on an API team, so it's useful to understand the context of all the stuff I'm going to talk about here. Because I'll give you an idea as I talk through this, what we're using it for and stuff. So Target's API platform. So we got mobile devices, .com, vendors, partners, and stuff that use all kinds of Target data. And we get that Target data to them through RESTful APIs. So products, locations, inventory, all kinds of them. There's about 30 APIs actually that we have. So we've got consumers, that are actually calling our APIs inside of Target and outside. And you've got systems, you can imagine, and maybe if you've worked on an API program, this data comes from anywhere. Really old systems, packages, you name it. So so think about that last one for a minute there. These providing systems, in many cases, they can be pretty slow, right? I mean, some of these things might be mainframe systems, like I said, legacy packages that are just not up to par for once we expose that data and get it really utilized really high. You can't call those providing systems. Some of them are pretty costly to call directly. Some of them are really old where they just can't scale. We can't actually make them go any faster for any reason. And then a lot of times we've got to take all this data that's in multiple layers. So imagine like location data. There might be several different systems that have this data. We've got to put it in one place. And then sometimes this data is just not even in good systems to begin with. Sometimes they're just in lists somewhere or something else. So a lot of times what we got to do is we got to get this data into a single place. So that's actually what our problem was, is all these things right here. And so you think about the existing tools, probably in your enterprise, right? You've got your traditional RDBMSs. Some of them are pretty costly, right? And if you think about the processes for your traditional databases, they're probably not a really good fit for what you're trying to do. And then if you just look at the suite of options that you have, you probably don't have that many vendors or tools to choose from. And so in our case, it was certainly a problem for us. And so we took a look at our existing relational databases, and one of the very first things that really jumped out at us is they're not multi-tenant. In our case, growing in multiple data centers, the data's being spread in multiple places. We've got guests all over the country, and we've got data centers only in certain places. And then, what if you want to go to the cloud with some of this stuff? Well, you start to think about, well, what are my options if I want to do those things, right? Another thing too is that if you're with the existing tools that are out there, do you have the ability to, control performance like you need to? If there is like a process for making changes to those relational databases, do you feel like you have all the control you have? I mean, I don't think we did. Availability, systems might have outages and other tools that you had. And then in our case, I'm going to talk about this a little bit more later, but are those things automatable, right? Are they being managed by hand? Are you using something like Chef or Puppet to manage them? So I remember it was about 2012, went out to QCon and was actually with another colleague from Target, Pete, he's here in the crowd. And we went to a Netflix presentation where Adrian Cockcroft was talking. And I mean, I'd been wanting to have a really good reason to try out Cassandra for some time. And I remember listening to Adrian talk, and this is actually just sort of, if there's any vendors in here, this is sort of the power of someone really influential mentioning your product. He said some yada yada about Cassandra. He's like, but honestly, if you're an enterprise, you're probably going to use data stacks, right? He just said it as a matter of fact. And I actually had never heard of data stacks before that prior. I mean, I might have like crossed, but it never like stuck in my mind like an indelible impression. But that certainly did leave me with an indelible impression. I went back and took a look at it, and I mean, I just literally, I just went back and approached Pete, and I was like, hey, you know, this problem's really been coming to a boil here. We should probably do something about it. So I just went to Pete, and they're like, hey, let's just do it. So we did. And keep in mind, we had tried other things in the past with, you know, mediocre success, trying other things. So it wasn't like we just irrationally made a decision. But I think the real power here is that if you're going to try something, just do it and let the results speak for themselves. Try to succeed fast or fail fast, either one, right? So let's talk about why the reasons trying were really attractive for using Cassandra. So in our case, it fit 80% of the need, and that's pretty good, right? Remember all these APIs, they got all kinds of tolerances they can have. You know, whether it's eventual consistency or just performance-wise, there's a whole range of different ways these APIs behave. Some of them, they're kind of batchy, some are more real-time. But so I'd say 80% of them was a really good fit. The other things about Cassandra is just the years in development. Had enough years under its belt where it wasn't, you know, a brand new technology. That makes it attractive. You know, in enterprise, obviously, there's a lot of people who will suggest, you know, don't chase the shiny penny, that type of thing. But in this case, it was very easy to say, you know, there's many of years of development under the project. And then there was a nice, rich ecosystem of developer tools and drivers and all kinds of stuff, right, for multiple languages. So that was really attractive. This is a big one, and it's something you don't want to underestimate. I think with existing enterprise tools, you've probably done this yourself. You try to troubleshoot them, or you want to make it, you want to try to look up some new feature. There's probably a paywall you have to go to, right? You got to sign into the vendor's website and stuff like that. The results have got to be Googleable. I mean, if they're not, you should really consider that as a very heavily discounted, you know, reason not to go with that tool. In this case, the community is very strong. There's lots of results on Google, and that actually makes a lot of difference because the people who are going to fix this stuff at 2 a.m. anyways are just going to Google anyhow to learn something they don't know. And then just a company who would support it, right? I mean, you can go with Cassandra, you know, normal Cassandra, or you can go with DataStax. It's nice to know that DataStax is there supporting it, and you can open up tickets with them, and they've got really good people to work with too, right? So that all was very attractive. I mentioned this earlier. We use Chef at Target, and Cassandra is entirely shuffleable, and I'll talk about a cool thing we released for the community later here, but it's shuffleable, and that's really important to us because we don't like to do things by hands. Humans make errors and stuff like that, right? Aligned really well with our existing investments, so you know, we're Java shop, the existing hardware we had worked out pretty decently. And then the last one, and this stuff matters, right? Because as developers, you want to make the right choices for your company, right? You want to make really smart choices so that your company's profitable. Sometimes working with some other vendors, right, you can't easily do that, right? You feel like you're getting gamed. When you think you're gaming the vendor, they're gaming you, right? You'll never win. They're masters at this stuff, right? So this frictionless sales model is really important to me, at least. So in this case, it's just very straightforward pricing. And there's a lot of other tools like that out there too, right, that are frictionless, and I'm drawn to those. And so that's a pretty big reason for it being attractive. So let's think about these adoptions as we thought and decided to bring it into IT after looking at the reasons it was attractive. Really the nature of this talk is bringing the stuff into enterprise IT, right, the nature of it. I think probably a lot of you can empathize with all the sort of things you run into. You know, one of the first things being you're going to have to sell it to people, right? You just can't cavalierly make the choice to do it on your own and go do it. You're going to have to talk to certain people who actually care about these outcomes that might have some concerns, et cetera. It just takes sticking to key message and talking to the right people. So this is, I mean, NoSQL for the first time. I mean, I think there were probably skunkwork projects of it in many places, but this was going to be production on a much larger scale. And so for some people, you have to do the extra work to tell them, like, yes, this is actually going to be the first time we're using NoSQL, and work them through that conversation. It's really important. Don't underestimate that. And then just the idea that we're going to be automating this, that was also a really big emerging thing a year ago. And so you couple that with us bringing this technology, kind of scary to do, but we had to sell that as well, right? We can't just have said, we're going to bring this in and use all the existing processes we have here inside of our enterprise. So that was a pretty big barrier to deal with. And then the last one, and I have to imagine that you encounter the same thing, the political aspects of it, right? So just having a really good leader on your team who's going to go to bat for you, who's going to not just write you the blank check, but also defend your choices and help sell that to all the other leaders across the organization who are, questioning what you're doing, who are curious, et cetera. So that's really important. And if you don't have that, you should definitely advocate for that, ask for that, raise awareness for it, et cetera. That's really important. So let's think about, once we decided to start using it, what were some of the things we know we were going to run into? So a lot of these providing systems for these APIs I was telling you about sometimes they have very batchy-like mechanisms for getting the data. And we knew that in our case, we're going to have to do a lot of bulk loading. And so, that's not an ideal way to be getting data into Cassandra. It's entirely possible, and we have to do it. We just knew that was going to be a challenge. Keeping Cassandra in sync, just all these providing systems, it's going to get interesting because, a lot of these systems aren't event-driven. They aren't real-time. Some of them are packaged software, which you're really limited. Then you can't modify them. It's really, the few interfaces those systems have, you have to deal with them. You end up having to write some, custom integration stuff to actually get that stuff into Cassandra. So let's talk about standing it up. A couple parts to this here. So this being one of the first distributed systems in the truest sense, we had Splunk. You guys might be familiar with that. That's a distributed system. And we maybe had some other ones. Oh, sorry about that. That was new to teams. And so, you're going to have to take the time to actually explain that to all those teams you're going to need to work with, your hardware partners, et cetera, because they're not going to know what these systems are. And it's really important for them to understand that because they're not centralized, there are things that they're going to need to do differently. The next point is obviously really key to this. So, and this is a common theme that you've even heard this morning in the keynote, and you've heard it anytime you've done engagement with Cassandra or data stacks, is don't use SAN, right? And that was actually a real barrier I think that all of us hit, and you just make you cringe a little bit every time it happens. But in this case, it's something we had to advocate for, to say, look, you really can't use SAN. This is a distributed system. You're destroying the distributed nature of this by making it centralized, right? You want to use the cheap disks on those cheap servers, right? Another thing too is that all of this emerging kind of in the same set of years. We're talking about SSDs here. Probably a lot of the teams where your infrastructure partners might be using spinning disks still. Obviously, you got to work through that type of stuff, and we had to. And then there's things like, if you're going to get these servers, they're going to give them to you, and there's an existing way they manage them, but because it's a distributed system, you need to manage it a little bit differently, right? So in our case, things like backups, monitoring, swap, stuff like that. Those are things you're going to be doing differently on those Cassandra servers that you probably don't want your existing infrastructure partners to set up in a certain way, right? So you're going to have to talk them around why these distributed systems are a little bit different. And then the last one is, they're going to give you servers, and at least in our case, we had a set of only a couple of configs you could choose from, right? And I understand why they have a limited amount of them, but in this case, remember, it's a distributed system, and you kind of don't want huge servers. So just make sure you don't settle for whatever they give you. Like I said, all these other points above, you're going to work with them, and you're going to talk to them and say, here's the reasons why you want to do these things differently. And that includes the type of server they're going to give you. Full stack ownership, I don't know if that's like a term outside of Target or not, but in this case, I don't know how it works in your enterprise, but there may be like a tendency to want to hand the systems off to another group who's going to manage them and stuff like that. In this case, we literally take quite a large deal of pride in our work, and we actually want to get those 2 a.m. calls. We want to make sure it's stable, it's ran the way we need it to be ran, etc. I highly recommend that. And so in our case, we're the ones who stood it up. We're the ones who op it and dev against it and everything else. Let's see here. Right, so closest to the problem, you're best suited to solve it. That's really key there. If you just keep thinking that over and over, that's really key to kind of the point there. And the other things you're gonna have to think about, and you've probably, if you were training earlier, or you've probably been in other talks today, you've got to tune Cassandra to meet your needs, right? So in this case, for our APIs, we had to do a lot of work. And those are obviously challenges that we still face today and we're getting better at, but know up front, don't underestimate the data modeling and any type of tuning that you're gonna need to do for your particular workload. Other thing is that these skills are low at the time a year ago. I think it's getting a lot better. You know, more and more companies are using it. People are getting in the job market, et cetera. Don't underestimate training your people. This is different. It is a different technology, right? So don't underestimate that. Make sure you get the training they need. In our case, we were very willing to do that, and it's something that worked out well for us, I think. And then the last one is be wary of the promises of consultants. So there, especially a year ago, there were a lot of companies were saying, hey, we've got people, but just make sure that you grill those people. Like, get your best Cassandra person you have on staff and just make sure they really know their stuff. Because I still think that, to the first point, there isn't a lot of talent. I mean, those other consulting companies might not have it as well. So just grill them, make sure they really know their stuff, right? On the development side of things, like I was alluding to, don't underestimate the data modeling stuff for people who are training on Wednesday. It really matters a whole lot because it matters a whole lot to the performance of your system and how you're going to use it. Getting used to the DataStax driver, getting your developers used to knowing how to write queries in the right way and everything else, not hurting the system. Encourage your developers to actually care about this, right? Care about the outcomes. I mean, you shouldn't have to say that, but I mean, that stuff does matter. Encourage, like the full stack ownership stuff, those developers are part of that ownership as well. So encourage them to like research things, make things better. When there's problems, own it, right? These are pretty simple things, but they need to be said, I think. And then the last one, it is easy to write bad queries, full table scans, filters, stuff like that. Like just make sure that everyone is sharing what they've learned, that they're making the right choices, and obviously take the time to give the feedback whenever your clients of Cassandra aren't doing things right. The other thing is, right, a lot of these developers have an RDBMS background. You're gonna have to take the time to explain the differences there. In our case, we start out with Osteonics, actually. And there were some things that made us switch to DataStax driver. I mean, obviously it was supported by DataStax. There were some features that were better. And I think Osteonics was using Thrift at the time whenever we started using it. I think it uses CQL now, but DataStax driver is CQL, so that made a lot of sense for us to switch. All right, so running it. What were some of those challenges? Right, lots of machines, don't do things by hand. It goes back to that automation point I was saying. You're gonna wanna use something like Chef or Puppet, in my opinion, to manage those, or Ansible, whatever your favorite tool is. But configuring those machines by hand you're just gonna introduce errors, and that's gonna be pretty bad stuff. In our case, we wrote Chef cookbooks. I'll talk about that here in a second. For standing up new nodes, getting them configured the right way, it just makes a lot of sense to use Chef to manage that and manage the state of those machines and the config drift and everything else. And to my earlier point is, remember, there's your infrastructure partners. It's a large organization, right? And I don't blame them for this, right? They're seeing these servers and thinking, whoa, these are configured very differently from our normal servers. We need to bring them back to how they should be configured. And they'll go in and turn on things like swap and stuff like that, or change other settings. And I totally understand why they're doing that, but you got to make sure that all those people who could potentially touch it are aware of things like this. So just be aware of that. And then just back to the common theme here where Cassandra is different. There's different failure modes with Cassandra, right? So as you're testing your app, you might have a traditional way about how you test things at all kinds of different layers, right? Just make sure you're thinking of those different failure modes that Cassandra has, as it comes to availability and stuff like that. And I recommend just turning off certain things to see how it behaves and see how your teams will respond to that stuff. In our case, we wanted to make logging really, really awesome. We had really good luck with doing that, nailing that pretty well with our whole API program and all the other tools we use. We wanted to make sure we applied the same thing to Cassandra. In our case, we can see anything. And that's extremely helpful because that allows us to troubleshoot things, make performance better, and everything else. In our case, I'm under the impression that not everyone does this, But in Cassandra, in the JMX interface, you can take that data and send it in real time to whatever your favorite logging tool is. In our case, we use Splunk. So, and I'll talk about the M-beams we use here in a minute, but that's extremely useful, right? Because that's just really raw logging data at the right level where you need to troubleshoot things and make things faster. The nice thing about, in our case, how we did this, and maybe you're doing the same thing, but if you're taking that event data, you can correlate it with your log data, which is depending on Cassandra. And if you've got those logs from Cassandra and your apps in one place, and you're seeing spikes in latency in your app, you're also seeing spikes in Cassandra, well, that allows you to make that correlation very easily. So, you know, I don't know what logging tools you use, but in Splunk, that's very easy to do. Just make sure that you consider that as you're thinking about what's my logging strategy gonna be. And these are just some of our useful M-beams. The key thing I got 2 slides on these. The key thing to think about these things here is we alerts on all these things here. I mean, not only do we like operationally use them to look at the health of the system and things like that, but we have alerts set up across these things. So for your logging framework, you're probably doing some monitoring, right? You're doing some alerting of some type. These are useful things to actually alert against as well. And you can see these later. So I was talking about that cookbook. Actually, just this week, Danny Parker, a person on my team, wrote the DataStax Enterprise Cookbook, and it's actually here on GitHub. It's publicly available. It's easy to remember /target/DSE-cookbook. Go out there and fork it. Pull requests are encouraged. It works. That is actually the cookbook that we use. So this is not watered down in some way. This is actually the cookbook we use. And we have really, really good luck with it. So we're pretty excited about this. And then another thing that Danny did is and this is in relation to all the things I was saying above, is he wrote a great blog post on tuning Cassandra, so check that out as well. The easy way to remember this is just target.github.io. That's where our Target Tech blog is. So what were the results of all this? I mean, really, we went from total newbies to production ready literally in 2 months. No joke, that moment I was telling you about earlier where I went to Pete and I was like, hey, let's go do this. We got all the hardware, did all our testing, app dev, and deployed to prod in 2 months. That's entirely possible. So if you're thinking about that in your own company, this is a bar. I mean, maybe it's set kind of high, maybe it's set average, I don't really know, but know that that's something you can take back to your leaders. The other big thing about this, and you can imagine the retail line of work, that we did this right before our peak season. So talking about Thanksgiving, Black Friday and stuff, and it went off flawlessly. It was great. It was a really good feeling. And it just, in summary, I think all of our top used APIs, millions of calls, use Cassandra and depend on it, and they depended on it during the peak season. What is the overall results? So we think about us starting to use this with our API, becoming a core tool we use within our API stack. The number of resources and functions we opened up in our APIs, and just growth in volume and usage of our APIs was 2,000% growth. That in turn allowed us to make those APIs a lot more attractive for internal and external developers to say, hey, cool, you guys are doing more stuff. Sweet, I'm going to use your APIs. And then just unlocking things we couldn't do before. We had to say no to a lot of feature requests that were coming in for our APIs because we knew we just couldn't do it. But with Cassandra, now it's entirely possible, right? It opens up a whole different set of doors that you didn't have before. And then there's other stuff like, it's something that if you're using automation to manage it, if you got really talented people who are full stack owning it and everything else, then you can do things like Agile and really make a change to the system, in a 2-week sprint. And then it gets us a lot closer to a continuous delivery. So we're full continuous integration, aspire to continuous delivery. That's hard, right? I don't think everybody in the room can raise their hands for that. But it gets you a lot closer, right? Because those changes are easy, it's nimble, et cetera. And then the other resulting cascading effects, right? So you brought it in our case we did, and more teams are using it, right? So, we've got other people here from Target who are now using it in other major projects inside of Target. We're sharing those cookbooks with them, the lessons learned, trying to share that knowledge. It's really important, everything you learn, try and document in a wiki in-house if you have that, or whatever way you want to share knowledge. And then it's opening up the door to other distributed systems, right? Like Kafka, our team uses that too. We can You can come talk to me about that on the side. These are all distributed systems. More of those distributed systems. If you do it once, it makes it a lot easier to bring in the other ones. So what's the future look like for us? Right, we're gonna use it across more APIs. That makes a lot of sense. Get rid of those spinning disks. We actually did. I just was reviewing this presentation and realized that when I wrote this, we actually did get rid of those. We had some left, but we're now on all on SSDs. And that makes a lot of sense, right? We've seen several talks here today that talk about get SSDs, like knock it off, quit thinking about it. You should definitely be using SSDs. Move to the cloud. So, I mean, a lot of the stuff, actually our Cassandra cluster is all in-house. Makes a lot of sense to go out to the cloud. In our case, we're looking at Google Compute Engine. It's really attractive. We've done some tests out there, and things are looking actually pretty good. It makes a lot of sense for us someday to consider that. There's more things we can automate down to the infrastructure. You know, in our case, we want to scale and geographically distribute outside of our data centers into that cloud. Make some more, you know, changes to the infrastructure. So, I mean, there's more to do on that front. Like I said earlier, went to that training on the data modeling, really opens up your eyes to like a few key, more advanced things where like, wow, that data modeling stuff really matters. You know, you're probably gonna stand your data model up the first time with your set of applications. You're gonna make a lot of mistakes. Just don't put yourself in a corner where you can't back out of that easily. Don't underestimate the value of the data modeling up front. That stuff really matters for performance. It matters a whole lot. When you try to connect the two from data model down to how that data is stored ones and zeros on those machines, like it matters a lot to understand that. Get away from that bulk loading stuff. Like there's probably some better things that we can do. Get away from that batch stuff. Chances are you're gonna have the same thing. Think of that stuff up front if you can. Gets rid of that compaction, process overhead stuff. And then other things, you know, someone here earlier today talking about Spark. That's great stuff. You know, we gotta get to do more of that event-based data loading and stuff like that. We probably gotta start using Spark and Kafka, so we can talk about that on the side if anybody wants to know more about that stuff. Yeah, what are some crazy things? Like Docker sounds really attractive, actually. It's entirely possible. We've done some tests on that, and especially when you think about going out the cloud with that, right? So you've got a lot of your cloud providers that can allow you to do that. It's worth considering, right? Something we're looking at too. And the obligatory, we're hiring, no, but seriously, we are hiring, and we actually have job openings, and we actually have a table downstairs in the partner pavilion.